Hands up, who here is afraid of spiders? I'm a former arachnophobe turned venom scientist and spider advocate. Because working with beautiful Australian spiders like Betty the golden orb weaver taught me that while spiders may look creepy, the real creepy crawlies are the blood-sucking parasites living inside us. Parasites are a huge problem for both human and veterinary medicine. Malaria kills over 450,000 people each year. And here in Australia, our sheep are being literally eaten alive by blood-sucking worms. They can drain sheep of as much as 10% of their blood every day. And the problem is that we can't treat these diseases effectively. The parasites have evolved drug resistance. So we need new drugs to protect ourselves. So I'm asking the question, what if we try fighting the creepies with the crawlies? Spider venoms evolved over millions of years to have thousands of unique compounds. Some of these are fast-acting, potent, and selective, which makes them a great starting point for drug discovery. My research aims to take these drug-like molecules from venoms and turn them into new antiparasitic drugs. But how do you go from venom to drug? You need 3 S's: spiders, sheep, and shit. I work on a blood-feeding gutworm of sheep called the barber's pole worm, and I use this as a model for parasitic diseases. But because it's a gutworm, its eggs come out in the feces, so it's my job to dig through buckets of sheep manure over and over and over to find the microscopic worm eggs. Once I have the eggs, I can add the venoms and find out which ones kill worms. Then I look for the active molecule and synthesize it, which allows me to study how it works and make sure that it's safe to use. For my research, I led the largest ever screen of venoms against parasites, testing over 250 venoms against blood flukes, hookworms, roundworms, and malaria. And I found spider venoms that can kill every parasite we tried. We even found a molecule in tarantula venom that paralyzes human worms at a lower dose than the best anti-parasitic drug ever discovered. And best of all, ours had no side effects in mice, making it a great clinical candidate. So, spider venoms could be the next generation of anti-parasitic drugs. We just have to brave the creepies to fight the crawlies.
Thank you so much, Samantha, for this wonderful talk. And I was wondering what kind of effects will have in our real life, say in the future, your kind of research, this research.
Well, the real goal of my research is to be able to develop new anti-parasitic drugs, which is critically needed because, here in Australia, we're very fortunate, and much of the world, Europe, for example, we don't even think about parasitic worms as a major issue. But the reality is that over 1 billion people worldwide are infected with parasitic worms. And we desperately need new medicines to be able to treat many of these parasitic diseases because we have drug resistance or a lack of efficacy. So what we're doing is hopefully finding new molecules that will be able to overcome that drug resistance. And the really cool thing about the spider venoms is that they work via completely new pathways. So the spider venoms are helping us to find new drug targets for the parasites as well. So it's looking to be a really sort of long-term pipeline of drug discovery against the parasites.
So who said science was glamorous, Samantha? I wonder what changed your mind in terms of working with spiders and how you can change other people's minds to get more people into this field.
Well, one of my key goals of doing FameLab is to help show people how beautiful and amazing and actually cool spiders are. The majority of them are actually not dangerous to people at all. For example, Betty the golden orb weaver is completely harmless to humans, and she's pretty happy hanging out here with me on my hand. And the way that I got over my arachnophobia was really through education, teaching myself about how awesome these spiders are, how they play a really important role in our ecosystem, and also exposure therapy. I was genuinely arachnophobic when I started my PhD, so I volunteered. I challenged myself to get over my fear by taking care of the spiders. Then I named them, so I had Beyonce the tarantula, Whitney Houston the funnel web, and once you name them, you get attached to them, and they're not so scary after all.
I have a very unserious question for you, Samantha. In all of that sifting through the sheep poo, what was the weirdest thing you found?
Oh, the sheep poo is probably one of, actually, funnily enough, my preferred poos to sift through because they just eat grass, so it doesn't smell so bad. It's been much worse when I actually work on other types of parasitic worms like human and dog, and you have to dig through those feces. Probably the weirdest stuff has been when I've been doing dissections to actually collect parasites from different animals, and I was dissecting some fish, and as we opened up the fish, there was this giant crustacean in the mouth, and it turned out to be a tongue-replacing isopod. Now, this is a crustacean that swims through the gills of the fish, grips onto the tongue, squeezes the tongue to death, and becomes the tongue of the fish. And as I was looking at these fish for the different parasites, every single fish I had these parasites in them, and sometimes multiple fighting to be the tongue of the fish. So, you know, in comparison, the spiders are lovely. The parasites really are the creepy crawlies here.
Thank you.